A vector is a mathematical object having two properties. It has a length and it has a direction. Or instead of length you could say size. And it's perfect to represent the vector with an arrow because it has those two properties. It has a direction and it has a size or a length. And you can have different directions and different lengths. You can also have a vector with zero length, then you just write it as a dot. Okay, a vector you can write like this. So you write a letter with an arrow above it. And there's another vector B. And the green one is called the zero vector because it has zero length. So you write as 0 with the arrow above it. The length of the vector or the size of the vector, you write that as by putting two vertical lines next to the vector. And for this one, it will be B, two vertical lines. And also for the green one, the 0 vector. In this case, you know what the length is. It's just 0, because it's a 0 vector. You can also write the vector in terms of components. So if you have A, then you can write the vector in terms of components. It's vector components. You can call it AX and AY. If we now limit ourselves to plane vectors, that is vectors living in a plane, then it has two components. So this is a vector written in vector components. For example, let's say I want to have this vector 2, 1. Then I can draw this in the coordinate system like this. That's a vector that should go two steps in the x direction and one step in the y direction. So you should go 2 here and 1 up. So that's that vector. So this is A, 2, 1. So this means how many steps we go in x direction. These are how many steps we go in y direction. Or if you take B, for example, let's take that as -1, 3. Then that's a vector going one step to the left in the negative direction and 3 steps up. So it goes up here. So minus means moving in the negative direction of the axis. If you had -3 in the y here, then we would have gone 3 steps down. It doesn't matter where a vector starts. For example, instead of starting at origin, we could just as well start it anywhere. We could, for example, start A here. And then we should have gone 2 steps in the x direction and 1 step up. So you could just as well draw A here. So this is also vector 2, 1. Note now that this way of representing a vector is a bit overloaded symbol, because we now know that this also could mean a point in the coordinate system or an interval. So you have to determine from the context what you mean. And here, for example, if you take this point here, what coordinates do that point have? It has 2, 1. So we see that this point has the same coordinates as this. But it's just because we started with the vector at the origin. If you take this point instead, it has coordinates 2, -2. So here we don't have the same as the point coordinates. But if we start with the vector in the origin, then the endpoint will have the same coordinates as the vector components. If we have a point here somewhere, for example, here is P, and here's another point, Q. Then if we draw a vector from P to Q, so this vector, then we call this vector PQ. So that's an alternative name for this vector. So the starting point P to the end point Q, so you can call it PQ. We can also calculate the length of the vector. So let's say we have a vector that is 3, 4 in vector components. What is the length of this vector? If we draw the vector here in our coordinate system, it is this vector, 3 steps in the x direction and 4 steps in the y direction. So here. But we see here that we have a right triangle here. So this is a right triangle. And now we know that this side, that's the length of vector A. And this side here has the length 4. And the other one has length 3. So we can calculate the length of this side here, the hypotenuse, by Pythagoras theorem. So we have that the length of A is 3 squared plus 4 squared. So the length of A squared is equal to 3 squared plus 4 squared, which means that the length of A is equal to the square root of 3 squared plus 4 squared. And this is 9 plus 16. So square root of 25, 5. So the length of vector A is 5. More generally, if I have a vector A, which has vector component AX and AY, then the length of vector A is just the square root of this. So AX squared plus AY squared.